The rumor spread through the American lines like wildfire in the summer of 1944. The Germans had a new supertank. 70 tons of steel and Fury armor so thick it could laugh at Sherman's shells. A gun so powerful it could destroy anything the Allies fielded from over 2 kilometers away. Allied intelligence called it the King Tiger. German crews called it invincible. American tankers called it their worst nightmare. The first reports came from British forces fighting around Caen in Normandy. On July 11, 1944, the 53rd Heavy Panzer Battalion deployed King Tigers against Allied positions. British tank commanders radioed back descriptions that seemed impossible. Tanks larger than anything previously encountered. Shells bouncing off frontal armor that appeared impenetrable. German tanks firing from ranges where British guns could not respond effectively. The psychological impact was immediate and severe. American intelligence officers compiled reports from multiple sources. British Second Army provided combat assessments. Soviet military intelligence shared information from the Eastern Front, where King Tigers had appeared. In August 1944, Free French resistance networks reported sightings of massive tanks being transported by rail through occupied France. Its armor appeared impenetrable. The sloped 150 mm glacis plate could shrug off almost any Allied shell. And even the thickest American or British guns struggled to do more than scar its surface. In theory, the King Tiger rendered every Allied tank on the battlefield obsolete the moment it appeared. To many, it seemed less a tank than a moving fortress, an embodiment of German engineering turned to its most fearsome purpose. But behind the awe lay anxiety. The tank's very existence challenged Allied assumptions about armor warfare. British gunners trained relentlessly to identify its weak points. Memorizing diagrams that showed where a shot might penetrate at close range, American crews drilled emergency maneuvers meant to outflank it, though few relished the idea of facing one in open combat. Soviet tankers, who had already endured years of fighting heavier German machines, simply gave it a grim nickname, the Monster. Ate still. Those who eventually faced the King Tiger discovered a more complicated truth. The tank's weight strained bridges, its complex transmission failed frequently, and its enormous appetite for fuel crippled mobility. It was a triumph of design and firepower, but also an emblem of Germany's strategic desperation, a weapon born too late, too heavy, and too few to alter the course of the war. Yet, as with many legends, the reality of the King Tiger proved more nuanced and, in many ways, more tragic. The tank's terrifying statistics hid a host of practical flaws. Its Maybach HL230 engine, originally designed for vehicles half its weight, strained under the immense 70-ton load. On paper, the King Tiger could reach 38 kilometers per hour. In the field, it often managed half that, if it moved at all. Transmission failures were common. Final drives shattered. Engines overheated and caught fire. Many King Tigers were lost not to enemy action, but to mechanical breakdown or fuel shortages that forced their crews to abandon them. Still, when the tank functioned, it was unmatched. Its long-barreled 88mm KWK-43 gun could destroy Allied armor at ranges exceeding 2 kilometers, distances so great that return fire was often futile. The combination of range, accuracy, and protection created a lethal equation. Whoever saw first, killed first. In open terrain, the King Tiger reigned supreme. But most European battlefields offered no such luxury. Narrow roads, soft ground, and dense forests turned the Tiger's advantages into liabilities. Its immense weight bogged it down in mud and shattered bridges behind it. Maneuvering through villages or forests was slow and dangerous. Allied tankers learned to exploit these weaknesses, drawing the Tiger into confined spaces, calling in artillery or airstrikes, or ambushing from the flanks where its armor thinned dramatically to the men who faced it. The King Tiger embodied both the zenith and the downfall of German armored warfare. It was an awe-inspiring weapon, but also a symbol of a nation that had begun to prioritize engineering marvels over practicality. Each tank consumed enough resources to build several Panthers or a dozen Stoogie 3 assault guns. Vehicles that might have mattered far more to Germany's defense, their arrival caused both excitement and anxiety among German commanders. The King Tiger was a marvel of design, but it was also a logistical nightmare. Transporting a 70-ton tank to the front required specialized rail cars and reinforced bridges. Luxuries increasingly scarce in war-torn France. Once offloaded, tanks could not cross many of Normandy's narrow roads or soft bocage fields without risking collapse or immobilization. Every movement had to be carefully planned, every liter of fuel rationed. Yet, when the first King Tigers of Schwerpanzer Piollung 503 rolled into position south of Caen in mid-July 1944, their mere presence altered the tactical balance. The Allies, still reeling from fierce German counterattacks, now faced something entirely new, a tank they could neither outgun nor outlast in open battle. As one British intelligence report put it, the enemy has introduced a tank which no Allied tank gun can yet defeat from the front. On July 18, 1944, the King Tiger made its combat debut during Operation Goodwood. The massive British offensive east of Caen, British armor advanced behind a devastating aerial bombardment, expecting shattered German lines, but the King Tigers, dug in along the ridge near Cagny, were waiting. Concealed in hold-down positions, they fired with surgical precision. Within minutes, entire squadrons of Cromwells and Shermans were burning. Crews recalled the horror of watching shells ricochet harmlessly off German turrets, only to see their own tanks erupt in flames seconds later. But even in victory, the flaws of the King Tiger began to show. The bombardment before the battle had disrupted supply lines and damaged roads. Several King Tigers broke down before firing a shot. Others ran out of fuel after only a few hours of combat. 2 had to be abandoned and destroyed by their crews to prevent capture. The weapon that had terrified Allied tankers proved devastating in short engagements, but it was a prisoner of its own design. It could dominate a field, yet not hold it. It could win duels, yet not wars. For the men inside, every mission carried the risk of mechanical failure as much as enemy fire. Abteilung 503, one of Germany's most prestigious heavy tank battalions. These men were not ordinary soldiers, they were among the most experienced tank crews in the Wehrmacht, handpicked to master and operate the most advanced armored vehicle ever built. Their combat experience on the Eastern Front had forged them into hardened professionals. They knew the limits of machinery and the chaos of mechanized warfare. Yet even they approached the King Tiger with a mixture of reverence and apprehension. The tanks, Maybach HL 230 engine. Originally designed for much lighter vehicles, strained under the 70-ton weight, maintenance crews quickly learned that prolonged movement could burn out gearboxes or snap drive shafts. Still, for the first time since 1943, these veterans felt they possessed a weapon that could match, even surpass the Soviet and Allied tanks that had been steadily eroding Germany's armored superiority when the 316 Funklank remote control Panzer Company received its complement of 5 King Tigers in early July 1944. It symbolized both the technological zenith and strategic desperation of the Reich. The remote control designation referred to their intended coordination with Borgward for demolition vehicles, small, radio-guided explosive carriers meant to clear minefields or destroy fortifications ahead of the advancing Tigers. In practice, this concept rarely worked as intended. The battlefield was too chaotic, the radio frequencies unreliable, and the fragile board words were often destroyed before reaching their targets. Still, to the German propaganda ministry, the arrival of the King Tiger was a public relations coup. Newsreels showcased the colossal tank-crushing obstacles and firing its 88mm cannon, accompanied by triumphant music and slogans about German ingenuity defying the world. Only a handful had reached the front, and fewer still were operational at any given time. As these 5 King Tigers moved into position near Caen, their crews understood that they carried not just steel and ammunition, but the hopes of a faltering nation. They were to spearhead Hitler's promise of vengeance, proof that the Reich still had teeth. But beneath the iron exterior lay a quiet truth. The King Tiger was as much a symbol of German engineering brilliance as it was of its impending collapse. Yet despite these drawbacks, the men could not help but feel awe. Inside the King Tiger, surrounded by layers of armor, thicker than anything they had ever seen, they felt invincible. The massive KWK-43L-71 gun extended like a spear into the future of armored warfare, a weapon capable of killing at ranges where the enemy could barely return fire. When the breech slammed shut and the first shell roared out of the barrel, the thunderous recoil made the entire vehicle shudder, a reminder of the raw power they commanded. Training was intense but brief. Time was something the Reich no longer had. Mechanics worked around the clock to keep the tanks running, dressing overheating engines, leaking fuel lines, and transmission problems that appeared after only a few hours of movement. The Maybach engines strained under the load, gears howled, and treads cracked under the tank's immense weight. But none of that dampened morale. These crews had faced far worse conditions in Russia. If the machines demanded care and discipline, they would provide it. They were veterans of endless retreat. And now, finally, they were being given the means to strike back. When the 5 King Tigers of 316 Funklank Panzer Company rolled out for their first live exercises, the ground trembled. Civilians and infantry stopped what they were doing to watch these metal giants crawl past. Soldiers compared them to moving fortresses, their engines growling like caged beasts. Commanders believed that, with such machines, no Allied tank could stand in their way. Still, beneath the admiration, a few officers whispered doubts. The tank's sheer size made them difficult to conceal. Their mechanical reliability was already in question, and the fuel there was never enough fuel. Each kilometer driven was a logistical burden. Each shell fired a precious expenditure. But for the men inside, such worries faded when they gripped the controls and peered through the gun sight. They had no illusions about the war's direction, but with a King Tiger, could at least go down fighting on their own terms. The mechanics leapt from their half-tracks and rushed to the stricken machine. They opened the access hatches and were immediately hit by the stench of burned oil and scorched metal. The transmission housing was cracked. The teeth of several gears had sheared clean off under the immense torque. Nothing could be done here, not on the roadside, not without replacement parts, not without heavy recovery vehicles that were already in short supply. The commander cursed under his breath. 10 kilometers. That was all it had taken. 10 kilometers before the mightiest tank in the world had crippled itself without a single shot fired. Orders came to tow it off the road, but even that proved nearly impossible. The King Tiger was simply too heavy. The other tanks could not risk their own transmissions by trying to drag it. In the end, engineers had to call in demolition specialists. With grim efficiency, they placed shaped charges inside the immobilized tank, set the timers, and stepped back. A dull, echoing explosion tore through the calm French air, sending a column of black smoke skyward. One of Germany's newest and most powerful weapons lay burning. Destroyed not by the enemy, but by its own design. The remaining 4 King Tigers pressed on. The crews exchanged uneasy glances, but said nothing. Every driver now treated his gearbox like glass. They moved in low gear, keeping their revs low, crawling forward at walking speed. Hours passed. Then, a second tank fell out of formation, this time overheating. Coolant leaked from a ruptured pipe. The engine began to seize. Again, nothing could be done in the field. The company commander radioed battalion headquarters, his frustration mounting. What had been meant as a triumphant debut for Germany's most advanced armor was turning into a logistical nightmare. By the time the surviving tanks reached their staging area near Villers-Bocage, only 3 of the original 5 were still operational, and even those showed signs of mechanical strain. The dream of unleashing a new wave of invincible armor was already crumbling under the weight of reality. German engineering had built a masterpiece, but one too complex, too fragile, too heavy for the collapsing infrastructure of a dying Reich. The driver noticed it first. A faint knocking beneath the steady roar of the Maybach HL230P30. At first, he thought it was a loose component, maybe a vibration from the uneven French road. But within minutes, the sound deepened into a sickening metallic hammering. The temperature gauge began to climb. Oil pressure dropped. A plume of thick, bluish smoke rose from the engine compartment. The commander immediately ordered a halt. The crew bailed out, throwing open the rear engine hatches as boiling coolant hissed into the air. The stench of burning oil and antifreeze filled the road. The mechanic's face went pale as he inspected the damage, a cracked cylinder head and a blown gasket. The engine, overtaxed by the sheer mass of the King Tiger, had overheated beyond recovery. The problem wasn't poor maintenance or a crew error. The cooling system, designed for a 45-ton Panther, simply couldn't dissipate the heat generated by an engine working double its intended load. The tank was finished. 2 out of 5 disabled, and not a single enemy shot fired. The road behind the column was now littered with broken machinery and pools of oil, a grim testament to the limits of even German engineering. The commander kicked at the dust, furious. Every kilometer forward felt like an act of defiance. It's against physics itself. The remaining 3 King Tigers pressed on through the countryside, crawling past the smoking wrecks of their mechanical brethren. Each crew grew quieter, more anxious. The mood of awe and pride that had accompanied their departure was gone. Every vibration, every strange sound, set nerves on edge. The drivers kept the engines throttled low, praying the next hill would not finish them too. Behind them, the sun dipped low over the hedgerows, casting long shadows over the convoy. Somewhere ahead lay the front, and with it their first real test against the Allies. But even before meeting the enemy, the truth was undeniable. The King Tiger's greatest foe was itself. The remaining 3 King Tigers pushed on in grim silence. No one spoke of the 2 hulking wrecks they had left behind, but every man knew what it meant. These were not teething problems. This was systemic failure. The pride of German engineering, the weapon meant to restore battlefield dominance, was dying mile by mile under its own weight. The column moved slowly now, barely 20 kilometers an hour on open roads. The drivers avoided rough ground, potholes, and sharp turns, terrified of overloading the fragile gearboxes. Every hill became an ordeal. The Maybach engines strained, coughing black smoke from their exhausts as the drivers feathered the throttles to prevent overheating. The immense weight pressed the suspension to its limits. Even the steel road wheels, each weighing over 200 kilograms, groaned under the strain by the time they reached the outskirts of Villers-Bocage. The remaining 3 tanks looked less like instruments of conquest and more like exhausted beasts. Dust coated their sides, their tracks squealed, and fuel consumption was catastrophic. Over 1,000 liters burned for a day's slow progress. One of the 3 King Tigers attempted to cross a small bridge over a country stream. The structure, built for civilian wagons, creaked ominously as the 70-ton monster rumbled onto it. The engineers had assured command that the bridge would hold on paper. Perhaps. In reality, the supports gave way halfway across. With a thunderous crack, the bridge collapsed beneath the tank's weight. The King Tiger plunged nose first into the creek, its massive gun slamming into the mud. The driver and radio operator barely escaped through the hatches before the rising water swallowed the lower hull. Recovery was impossible. The other crews could do nothing but watch as their comrades' machine slowly filled with water. Another casualty. Not of enemy fire, but of physics and overambition. 3 lost. 2 remaining. The surviving pair continued toward the front. Their commanders grim, but determined to at least bring their steel monsters into combat before mechanical fate caught up with them. They would not suffer the humiliation of breaking down without firing a shot. Ahead, the distant rumble of Allied artillery promised what they had trained for, a chance to prove the King Tiger's worth in battle. The mood among the surviving crews turned from pride to disbelief, and then to quiet dread. The myth of the invincible tiger had dissolved somewhere along those dusty French roads, replaced by the grim realization that their greatest weapon was destroying itself before it even met the enemy. The company commander radioed back to headquarters, his voice tight with controlled anger. The message was simple. 3 vehicles immobilized by mechanical failure. Request recovery assistance. Continuing advance with 2 operational units. There was no reply for several minutes, perhaps. because Command already knew what he was discovering firsthand. The King Tiger, the supposed savior of the Reich, was too heavy to fight a mobile war. The mechanics worked feverishly to salvage what they could from the broken tanks, spare parts, ammunition, tools, even rations. But the sheer size and complexity of the vehicles made field repairs impossible. The wrecks would have to be abandoned, left as monuments to flawed ambition. Villagers watched in stunned silence as German soldiers, once the epitome of military precision, stood beside their motionless steel giants, helpless. For the two remaining tanks, every kilometer forward now felt like borrowed time. The drivers treated the gearboxes like porcelain, shifting with exaggerated care. The engines idled at the lowest possible revolutions to conserve fuel and reduce heat. Yet every sound, the grinding of gears, the metallic rattle of the tracks, the labored hum of the cooling fans felt like an omen. They advanced at a crawl, covering barely 10 kilometers an hour until at last. Distant thunder rolled across the horizon. Artillery, British guns. The front was close now, closer than ever. Inside the lead, King Tiger, the commander, Hauptmann Weber, adjusted his binoculars and saw the faint smoke columns marking British positions near Hill 112. Finally, after days of mechanical misery, they would fight. The crews tensed, the gunners checked their sights, loaders handled the 8.8-centimeter shells with reverent precision. This was the moment they had been promised, the chance to prove that the King Tiger was still a weapon to be feared. The last King Tiger rumbled on through the dusk, its engine growling like a wounded animal. The countryside rolled past in shades of gray and smoke, the distant thunder of artillery marking the unseen front. Inside, the crew said little. Each man listened to the labored heartbeat of the Maybach engine, half expecting it to seize at any moment. The tank commander, Hauptmann Weiss, stared through his periscope, the glass smeared with dust and oil. His orders were clear: reach Tilly, join the remnants of the Panzerlehr division, and hold the line. But there was no line anymore. Just fragments, isolated pockets of men retreating through burning villages. The proud divisions of yesterday now little more than names. The King Tiger was a fortress of steel, but it moved through a wasteland of defeat. 30 kilometers from Tilly, the crew stopped to refuel from a jerry can. The massive vehicle drank greedily, nearly 100 liters gone in minutes. The driver wiped sweat from his brow, the air inside the hole thick and metallic. "We won't make it," he muttered. No one argued. At dawn, the tank crested a low hill. In the distance, they saw the blackened wrecks of Panthers and Stooges lining the roadside, ghosts of the Panzerwaffe's former might. The King Tiger advanced slowly, its treads grinding over the stones. Then, for the first time in hours, the engine coughed. Once, twice. A shudder ran through the steel hull. Weiss held his breath. Then, mercifully, the engine caught again. When they finally reached Tilly, what awaited them was not an army, but a handful of exhausted infantrymen and a single functioning half-track. The last King Tiger rolled into position beside a hedgerow, its camouflage chipped and scorched, its crew hollow-eyed. They had made it, but to what end? That evening, Allied artillery began to fall on the town. The crew closed their hatches and manned their stations. The gunner loaded a single shell. The loader whispered a prayer. The King Tiger fired once into the growing darkness, the recoil shaking the earth. Then another barrage answered from beyond the horizon. When the sun rose over Tilly the next morning, the great tank stood silent, its gun pointing uselessly toward the west. Smoke drifted from the turret vents. Around it lay the ruins of the town and the broken symbols of a dying war machine. The legend of the King Tiger would live on in photographs, in reports, in the minds of men who never saw its failures up close. But for those who had served inside one, the truth was different. The King Tiger was not a beast to be feared. It was a monument to desperation, magnificent, terrifying, and doomed from the start. The demolition charges were placed carefully under the turrets, along the engine decks near the ammunition racks. There was no ceremony, no salute. Just a handful of weary mechanics and engineers doing what had to be done. They stepped back, gave a nod, and the charges detonated in a dull, rolling thunder that echoed across the empty fields. Flames licked from the torn holes, black smoke coiling into the sky. The most advanced tanks in the world, destroyed not by enemy fire, but by the hands of their own creators. When Allied reconnaissance aircraft flew over the area days later, they photographed the scene with curiosity. The massive wrecks were unlike anything they had yet encountered in France's colossal shapes, with sloped armor and turrets. Larger than a man's room, intelligence officers pored over the images, trying to determine what new monster Germany had unleashed. It would be weeks before they learned the truth. These were not new weapons entering the field, but the failed promise of one that never truly arrived. For the engineers back in Germany, reports from the front confirmed what many had already feared. The King Tiger's design, though formidable on paper, was beyond the capacity of the Reich's shrinking industrial base. Each tank required over 300,000 manos to build. Its engine strained constantly against its own weight and its complex suspension. Though ingenious in theory, could not endure the realities of campaign conditions, yet production continued. Orders were signed, quotas raised, and propaganda films spoke of invincible wonder weapons that would turn the tide. The truth was the opposite. Every King Tiger built drained resources that might have sustained 10 lighter, more practical vehicles. The supertank had become a symbol of the delusion gripping the German war machine, a belief that brilliance could substitute for logistics, that engineering could defeat arithmetic. When Allied troops eventually reached Châteaudan, they found the 5 hulks still smoldered in places. Their armor split open, revealing the intricate machinery within. To the soldiers who examined them, they seemed at once terrifying and absurd, magnificent constructions rendered utterly useless by their own excess. One British sergeant is said to have remarked, "If this is what they call progress, we can only thank God for their engineers." And so the first 5 King Tigers vanished from the war before they had even begun to fight. Victims not of enemy firepower, but of a nation's overreach, their story would be repeated again and again. From the forests of the Ardennes to the ruins of Berlin, steel giants built to conquer the world, undone by their own weight. The reports were exhaustive. Every plate of armor was measured, every weld inspected. The turret traverse system, massive and slow, was tested under power. Technicians marveled at the quality of the steel, the complexity of the transmission, and the sheer scale of the gun. The 8.8 centimeters KWK-43 could punch through any Allied tank in existence. On paper, it was the apex of tank armament. In the field, it was chained to a mechanical nightmare. Investigators noted the gearbox failures, the track, wear, and the countless maintenance points that required specialized tools. The drive sprockets had to be removed with a portable crane. Even changing a road wheel could take hours. The suspension, with its overlapping wheels, clogged instantly with mud and ice. The cooling system, designed for ideal test conditions, overheated under combat loads. To keep one operational required a team of mechanics, a steady supply of spare parts, and fuel reserves that the collapsing Reich could no longer provide. The Americans photographed everything. They cut open armor samples for metallurgical analysis, discovering subtle differences between German high-carbon steel and the Allied equivalents. They noted the fine machining tolerances, the heavy reliance on precision bearings, the scarcity of standardized components. To the engineers who studied it, the King Tiger was both an object of admiration and a warning. It represented what happened when design brilliance ignored practical necessity. British officers, as more cautious in their praise, remarked that no empire at war can afford to build tanks that break their own backs. The Americans agreed. Their own production lines in Detroit and Chicago could turn out dozens of Shermans for the cost and effort of a single Tiger II. Quantity, not perfection, was what won campaigns. The captured King Tiger was eventually shipped to testing grounds in England. There it was repaired, repainted, and run through a series of trials. The results confirmed what the wrecks in France had already shown. The tank was formidable as a fortress, disastrous as a weapon of maneuver. The transmission failed before the tests were complete. For Allied intelligence officers, the message was clear. Germany's supertank had achieved what Allied firepower could not have had, defeated itself. The optics impressed them particularly. Through the German TZF-9B sight, the world appeared with a clarity none of the Allied crews had ever experienced. The glass was flawless, the magnification steady even under vibration, and the range markings so precise that an experienced gunner could hit a target on the first shot at over a mile. Allied tank optics, by comparison, felt crude serviceable, but nowhere near the refinement of this engineering. To the technicians examining the sight, it was clear that Germany had spared no expense. Every lens, every screw, every machine's surface spoke of craftsmanship bordering on obsession. And yet, that same obsession was the tank's undoing. Each optical unit required hours of skilled labor and materials that Germany no longer had in abundance. Factories bombed, supply chains broken, technicians drafted or dead. The Reich could no longer afford such precision. What had once been an advantage now strangled production. As the analysis continued, the pattern became undeniable. The King Tiger was a masterpiece of design, but it was also a monument to inefficiency. Its complexity demanded a level of maintenance and supply that simply did not exist by 1944. For every kilometer it advanced, it consumed liters of precious fuel. For every hour it ran, something needed repair. To field even a single company in combat condition required logistical resources that could have supported an entire armored division of medium tanks. Still, among the Allied engineers, there was a grudging respect. The design philosophy was clear: build the most powerful tank in the world, regardless of cost. If the Tiger II had appeared in 1942, before Germany's fortunes turned, it might have rewritten the course of the war. But by 1944, it was an anachronism, an armored giant born into a war that no longer had room for giants. Reports from the technical teams filtered upward through command channels. Generals and ordnance officers read the findings with interest, some with disbelief. The words nearly invulnerable front armor appeared again and again in the summaries. But so did another word: immobile. The tank's formidable protection came at the price of speed, flexibility, and reliability. In the end, even the most optimistic assessments concluded that the King Tiger was less a weapon of war than a mechanical fortress, unstoppable only in theory. When the last inspection team departed, they left behind more than just data and photographs. They left with a sense of relief. Relief that such a machine had been born on the losing side. The Maybach HL230P30 produced 700 horsepower, perfectly adequate for the 45-ton Panther. But in the 69-ton King Tiger, it was hopelessly overmatched. The power-to-weight ratio fell to less than 10 horsepower per ton, barely enough to move the machine across level ground, let alone through mud, hills, or debris. In testing, engineers calculated that the massive tank consumed nearly a liter of fuel for every 100 meters traveled. On the open road, it could reach 38 kilometers per hour. In real terrain, half that, often less. Prolonged movement overheated the engine, warped the cylinder heads, and strained the cooling system beyond capacity. American technicians inspecting the captured tank noted signs of heat damage around the engine compartment: discolored metal, burned insulation, cracked manifolds. Several of the coolant lines showed evidence of field repairs with improvised fittings. These were not the marks of combat. They were scars from simply trying to keep the machine running. The engineers shook their heads. The King Tiger's power plant was an extraordinary example of what happens when theory outpaces practicality. On paper, it was a marvel of compact design: 12 cylinders, 4 carburetors, high compression, a forced lubrication system. In the field, it was a liability. Every additional ton of armor, every millimeter of plating, every luxury of precision increased the burden on that single overstressed engine until it became the tank's fatal weakness. One American officer summarized it bluntly in his report: the Tiger II possesses the firepower and protection of a battleship, but the mechanical endurance of a farm tractor. The findings confirmed what frontline crews had already learned through bitter experience. The King Tiger was invincible only as long as it didn't have to move. Once in motion, it became a victim of its own design. In Normandy, in the Ardennes, across the Eastern Front, the pattern repeated. Broken transmissions, burnt-out engines, and immobilized hulks left by the roadside, each one a testament to German engineering brilliance turned self-destructive to the Allied engineers and officers who pored over the data. The lesson was stark and immediate. No amount of armor or firepower could compensate for a lack of reliability. A tank that could not move was already defeated. The implications were grim. Every kilometer the King Tiger traveled was a battle against its own mechanical limits. Even minor maneuvers on soft ground or slopes could overtax the engine. Field reports corroborated what the American engineers had deduced. Breakdowns were not the exception, they were inevitable. Crews became mechanics as much as gunners, constantly monitoring gauges, adjusting coolant flow, and nursing the transmission and engine through every operation. When Allied forces encountered abandoned King Tigers in Normandy and later across France, it became clear that the most formidable German weapon was undone by logistics and engineering hubris. Tanks that could theoretically dominate a battlefield were rendered immobile by terrain, mechanical strain, and fuel scarcity. In many cases, entire German armored operations ground to a halt. Because the supposedly invincible tanks could not be maintained in sufficient numbers to fight coherently, the American technical teams noted another critical issue. Repairs in the field were nearly impossible. The King Tiger required specialized tools, spare parts that were rare even in German depots, and trained mechanics. Roadside breakdowns often meant permanent loss. Tow operations were perilous. The weight of the tank made recovery by any standard tractor or half-track nearly impossible, and many attempts ended with the towing vehicle itself damaged or destroyed. In short, the King Tiger was a paradox. On paper, it outclassed every Allied tank in armor, firepower, and optics. In practice, it was fragile, unwieldy, and a logistical nightmare. Its design represented the apex of German engineering skill, but also the limits of practical warfighting. The engineers' reports concluded that while the King Tiger could theoretically dominate a duel, the realities of combat terrain, supply, maintenance, and reliability meant that it rarely could reach that point. Field experience had already proved it. Across Normandy, the Ardennes, and the Eastern Front, the pattern was repeated. Broken tanks abandoned on roadsides, immobilized hulks littering the landscape, and a few rare survivors arriving at their objective only after extraordinary effort. Victory on the battlefield required more than superior firepower. It required machines that could be counted on to move, to operate, and to survive. In that metric, the King Tiger had failed spectacularly. Soviet engineers tested the King Tiger's armor by firing captured German 88mm, KWK-36 and KWK-43 guns at close and medium ranges. The results confirmed what Allied analysts had already suspected. The frontal armor was nearly impervious to most contemporary weapons. Shells that could penetrate a Panther simply bounced off the glacis and turret front. Side and rear armor, while thinner, still required specialized high-velocity rounds for penetration. The Soviets noted that the tank could dominate in a stationary defensive role, but only under ideal conditions. Mechanical fragility, however, rendered that advantage largely theoretical. Every mobility test revealed limitations. Tracks detract under heavy stress. Suspensions sagged and fractured, and engines consistently ran at temperatures approaching failure. During river crossing tests, both tanks struggled to maintain traction on muddy banks, and the rear drive sprockets of one tank seized entirely. Soviet engineers concluded that sustained offensive operations would have been nearly impossible without extensive logistical support and constant mechanical attention. Fuel consumption further underscored the impracticality of the design. Even with full tanks, the King Tiger's operational range on rough terrain rarely exceeded 80 kilometers. Any extended advance would have required fuel trucks traveling dangerously close to the front lines, exposing vital supply lines to attack. Soviet analysts noted that in contrast, their own T-34s, lighter and simpler. Could cover far greater distances with fewer breakdowns and far less logistical overhead. The testing at Kubinka made one point painfully clear. While the King Tiger represented the pinnacle of German armored engineering in terms of protection and firepower, it was fatally compromised by its drivetrain, cooling system, and sheer weight. Its dominance on the battlefield depended entirely on ideal conditions and heavy maintenance. Luxury Germany no longer possessed by 1944 Soviet reports. Later circulated among top commanders described the King Tiger as a weapon, whose strengths were real, but whose weaknesses made it more a liability than a strategic asset. The tank's story, engineers concluded, was a cautionary tale. Superior engineering cannot compensate for impracticality in a modern, mobile war. The reports were groundbreaking. For the first time, Allied tank crews had reliable, empirically verified data on the very machine that had inspired fear across Europe. Intelligence Bulletin No. 184 meticulously detailed armor thickness, gun penetration, drivetrain limitations, engine performance, and logistical requirements. Commanders could now plan engagements with confidence. Knowing that the King Tiger's vaunted invincibility had critical weak points, field officers studied the bulletin closely. The emphasis on final drive vulnerabilities and mechanical fragility changed tactics immediately. Ambushes were no longer about matching firepower, but exploiting terrain to force maneuvering that could overstress the German supertanks. Tank platoons learned to isolate King Tigers, attack their flanks, and avoid direct frontal assaults unless overwhelming numbers or artillery support were available. Artillery officers coordinated precise strikes on bridges and choke points. Understanding that a mobilized King Tigers were far easier to destroy than moving ones. The technical data also influenced Allied armor doctrine. Sherman crews became more aggressive. Knowing that sustained contact or repeated maneuvers could expose the limitations of their enemy, logistics officers incorporated intelligence on fuel consumption and maintenance requirements, targeting supply lines and repair depots to further neutralize the King Tiger's battlefield effectiveness. Soviet engineers' findings reinforced these conclusions. Reports from Kubinka were shared with frontline commanders, emphasizing overheating, transmission failures, and the high vulnerability of side and rear armor. Combined with intelligence from the Western Front, the Allies possessed a comprehensive understanding. The King Tiger could dominate a battlefield in theory, but in practice, it was a machine of extremes, powerful yet fragile, imposing yet slow, formidable yet inherently vulnerable. Ultimately, the story of the King Tiger became more than a tale of engineering marvel. It was a case study in the limits of over-engineering under wartime conditions. A reminder that the deadliest weapon is not always the one with the thickest armor or the largest gun, but the one that can move, endure, and sustain operations under the harsh realities of combat. American armored commanders incorporated this insight into planning almost immediately. Infantry and artillery units coordinated with tank squadrons to channel King Tigers into terrain that would strain their mobility's soft ground. Narrow roads, steep inclines, or urban streets. Sherman and Firefly crews were trained to avoid direct frontal confrontations, unless absolutely necessary, instead targeting flanks rear, or forcing movement that could induce overheating or transmission failure. Allied artillery also exploited the King Tiger's logistical Achilles heel. Supply lines, fuel depots, and repair points became high-value targets. A King Tiger deprived of fuel or spare parts was a fortress without walls, a weapon whose offensive potential was nullified by simple attrition. Intelligence officers emphasized that mechanical reliability, not firepower alone, determined operational effectiveness. The King Tiger's legacy extended beyond the war. Both American and Soviet post-war tank designs reflected the lessons learned. Balanced mobility, maintainability, and logistical practicality became as critical as armor and armament. Tanks like the M26 Pershing, the T-54, and the Centurion incorporated powerful guns and effective protection while emphasizing reliability and sustainment, direct answers to the mistakes revealed by the King Tiger's design. In the end, The King Tiger stood as a paradox. It was a marvel of engineering, a symbol of ambition and technical prowess, yet simultaneously a cautionary tale of overreach. Where it succeeded defense from prepared positions, it could dominate. Where it failed extended operations, rapid maneuvers, and harsh terrain, it could not even reach the battlefield intact. The legend of the King Tiger persisted, inflated by fear and propaganda, but the reality, documented meticulously by Allied and Soviet engineers, was far more instructive. The greatest German tank of the Second World War had been undone not by Allied firepower, but by the immutable laws of physics, logistics, and the unforgiving demands of war. The operational limitations of the King Tiger extended far beyond mechanical failures. Its massive weight restricted movement across bridges, roads, and difficult terrain, forcing commanders to funnel these monsters along predictable routes. This predictability made them vulnerable to artillery strikes, air attack, and ambush. Hills, soft soil, and narrow streets became obstacles rather than avenues for maneuver. Every kilometer of advance compounded stress on engines, transmissions, and suspension systems. Increasing the likelihood that the tank would fail before reaching combat, fuel consumption exacerbated the problem. At 190 gallons to cover just 120 kilometers on roads and, often double that, off-road that. King Tiger required an extensive supply chain just to reach the front. Germany's fuel shortages in 1944 meant that even fully operational tanks were frequently immobilized. Not by enemy fire, but by lack of fuel. In contrast, the Sherman and other Allied vehicles could cover twice the distance with less logistical burden, allowing for far greater operational flexibility. Production figures revealed the strategic consequences of such over-engineering. Only 492 King Tigers were built during the entire war. A single tank in 1943, 379 in 1944, and 112 in 1945, before production ceased entirely. This paled in comparison to other vehicles. 35,000 Panzer IVs, 6,000 Panthers, and over 50,000 Shermans built by America alone. Even if every King Tiger had been deployed perfectly, their numbers were insufficient to influence the broader course of the war. In sum, the King Tiger's brilliance in design came at the cost of mobility, reliability, and mass production. It could dominate a battlefield in theory, but in practice it was constrained by fuel, terrain, mechanical fragility, and scarcity. Germany had created a supertank, but it was a weapon whose strengths were neutralized by its own engineering, its own logistical demands, and the realities of total war. The King Tiger's legacy was not one of battlefield supremacy, but a cautionary tale of ambition outstripping practicality. Even on the specially reinforced flat cars, the journey was perilous. The immense weight of each King Tiger strained couplings, bent rails, and occasionally caused derailments. Bridges along the route had to be carefully assessed, and some sections required temporary reinforcement or complete bypass. Crews traveled alongside their tanks armed with wrenches and spare parts, anticipating breakdowns at every junction. By the time the Schwer Panzerabteilung 501 reached southeastern Poland, the battalion was a shadow of what it had set out to be. Of the 45 King Tigers, only 8 were operational. 37, fresh from the factory and technically new, had succumbed to mechanical failure en route. Transmissions locked, engines overheated, suspension components fractured, and track links deformed under the strain. The promise of Germany's most advanced weapon had evaporated on rails and roads. Long before any engagement with the enemy, field commanders faced an impossible choice: wait for repairs that required resources they did not possess, or commit the few functional tanks to combat. Fully aware of the fragility of each vehicle, the psychological impact on crews was profound. Soldiers who had trained and rehearsed for the might of the King Tiger now faced the stark reality that their most powerful tools could fail at any moment. Not from enemy action, but from their own complexity. Strategic bombing by the Allies had compounded the problem. The repeated destruction of the Henschel factory in Kassel and surrounding industrial infrastructure slowed production and disrupted supply chains. Machine tools were obliterated, assembly lines halted, and highly skilled technicians killed or scattered. Production dropped precipitously from over 100 King Tigers per month in the summer of 1944 to just 30 per month by year's end. Each tank lost precious weeks to the combined effects of industrial attrition and mechanical fragility. The calculus of industrial warfare was cruelly simple. For the resources invested in a single King Tiger labor materials, skilled engineers Germany could produce multiple Panthers or Panzer IVs, vehicles that were less individually formidable but far more reliable, mobile, and numerous. The disparity between design brilliance and practical utility was laid bare, leaving no doubt that the King Tiger, for all its legendary, fearsome reputation, was ultimately a weapon of diminishing returns. The losses at Uglando underscored the King Tiger's dual nature: lethal when properly positioned, yet vulnerable under even limited tactical miscalculations. The 8 operational tanks that had survived the road march represented Germany's cutting-edge armored force, but even they could not overcome terrain, enemy ambushes, and the inherent vulnerabilities of their design. Side armor, while substantial, was far thinner than the glacis or turret front, and exposed the vehicle to well-placed anti-tank fire. The aftermath of the battle prompted immediate doctrinal adjustments. Storing ammunition in the hull rather than the turret mitigated catastrophic detonations from penetrating hits. Even though it reduced the number of ready rounds available during rapid engagements, crews now had to balance survivability against combat efficiency, a compromise that illustrated the practical limitations of the King Tiger's engineering. Mechanical reliability remained a constant concern. The surviving King Tigers required near-constant attention from maintenance teams. Engines overheated in the August sun, transmissions groaned under every maneuver, and final drives were carefully monitored to avoid sudden failure. Each kilometer of advance risked another immobilization. Commanders learned quickly that these tanks, for all their firepower, could not be treated as expendable assets in offensive operations. The events at Uglando became a case study for both German and Allied forces. For the Germans, it highlighted the tension between raw firepower and operational mobility. For the Allies, intelligence reports combined with field observations revealed that even the most feared German tanks could be neutralized through careful positioning, flank attacks, and exploitation of mechanical weaknesses. The King Tiger's reputation as an invincible weapon began to erode in the face of practical battlefield realities. Even in victory, the King Tiger's presence imposed heavy logistical and tactical constraints. Every operational tank required fuel, spare parts, and maintenance crews. While the immobilized majority clogged roads and disrupted maneuvers, by late August 1944, the Uglando engagement had proven that Germany's most advanced armor could be decisive, but only under optimal conditions, a rarity in the fluid, attritional combat that defined the Eastern Front. During the Battle of the Bulge, the King Tigers were deployed en masse in an attempt to spearhead the German offensive through the Ardennes. The improved mechanical reliability was immediately apparent. Fewer breakdowns occurred during road marches, and crews reported that strengthened drivetrains and wider tracks allowed tanks to traverse soft, muddy terrain that had immobilized earlier models. Engines ran cooler thanks to enhanced cooling systems and better maintained seals, and driver discipline reduced. Unnecessary stress on transmissions, yet even these improvements could not overcome the fundamental limitations of the design. Fuel shortages remained severe, forcing units to limit operational range and pace. Complex terrain, narrow roads, dense forests, and steep hills continued to impose severe strain, and the tanks were still constrained by bridge weight limits. Maintenance teams struggled to keep pace with minor breakdowns, and any major mechanical failure required heavy recovery equipment, which was increasingly unavailable. In combat, the King Tiger's strengths were undeniable. In defensive positions or prepared ambushes, they could dominate American armor, outgunning and out-armoring nearly every Sherman or Firefly in the theater. Yet the offensive thrusts of the Ardennes revealed that mobility remained the tank's Achilles heel. Units often advanced more slowly than infantry, and any mechanical failure along the way disrupted the entire operational tempo. The lessons were clear. While hard-earned improvements increased the King Tiger's operational readiness to 59%, by March 1945, the combination of weight, logistical demands, and the deteriorating German war economy meant that even a more reliable King Tiger could not change the strategic picture. In practice, the improved designs were still tactical weapons, formidable in localized engagements, but incapable of sustaining prolonged operations at scale. The Battle of the Bulge became the final proving ground for the King Tiger. It demonstrated both the potential of the vehicle when properly supported and the enduring vulnerability imposed by its own size, complexity, and dependence on scarce resources. Even in its late war refined form, King Tiger remained a symbol of engineering brilliance constrained by the realities of industrial and operational limits. Tank 213, under Dahlinger's command, became the spearhead of the remaining offensive force. The 6 operational King Tigers were now both the symbol and the practical backbone of Piper's dwindling armored strength. Each kilometer of advance was a test not only of firepower, but of mechanical endurance. Engines groaned under the cold December air, transmissions hissed, and suspensions creaked with every uneven cobblestone and frozen rut. By the time Piper's force reached Loss, the logistical and mechanical attrition had reduced the offensive's momentum to a crawl. The remaining King Tigers moved cautiously, their drivers painfully aware that any mechanical failure could strand the tank and its crew behind enemy lines. Dahlinger, sitting high in the massive turret of 213, constantly monitored gauges, listening for the subtle changes in engine pitch that indicated impending failure. Despite these limitations, the tank's combat power was undeniable. On December 19th, American reconnaissance units probing Piper's position encountered 213 and the other King Tigers near the outskirts of Lawes. The German tanks gauged their 8.8 centimeters guns cutting through the light armored vehicles with devastating effect. The range advantage and superior optics allowed Dahlinger to destroy targets before they could effectively respond, but the offensive had lost its operational tempo. Every maneuver stressed transmissions and final drives. Fuel was limited, forcing careful rationing and coordination with the few operational fuel trucks that had survived the advance. The remaining tanks could not advance rapidly or pursue retreating forces. The mechanical reality of the King Tigers constrained tactical options, forcing Piper to consolidate his position rather than exploit fleeting successes. Tank 213 became the focus of attention. Its crew experienced the constant tension between lethality and vulnerability. Every decision whether to advance, turn, or engage carried the risk of mechanical failure. Dahlinger's awareness of both the tank's strengths and limitations exemplified the paradox of the King Tiger, a weapon of near-mythical power, yet one whose potential was perpetually constrained by engineering, the logistics, and the realities of late-war Germany. With its main gun disabled, Tank 213 became a stationary fortress rather than a mobile weapon. Dahlinger's crew scrambled to engage targets with the secondary armament, Schikanzel weapons, but against advancing American armor, these proved largely ineffective. Tank 221, commanded by Hanisch, continued to provide covering fire. But the concentrated American advance forced the King Tigers to rely on terrain and defensive positioning rather than firepower alone. The Americans pressed forward, taking advantage of every fold in the valley to reduce exposure to the King Tiger's superior main guns. Artillery support targeted suspected King Tiger positions, further restricting their mobility and forcing the German crews to hunker down behind natural cover. Despite the tank's near-invincible frontal armor, side shots and near misses caused spalling and minor mechanical damage, gradually reducing their combat effectiveness. As the engagement dragged on, mechanical strain began to manifest. Engines overheated from repeated bursts of maneuvering. Suspensions creaked under constant repositioning, and final drives were pushed to their limits. Every defensive action came at a cost, highlighting the tension between the King Tiger's legendary firepower and its operational fragility. Dollinger's crew, fully aware that their main gun was disabled, focused on survival and maintaining their position to the last possible moment. The psychological pressure was immense. The King Tiger's aura of invincibility was undermined not by overwhelming enemy firepower, but by the combined effects of chance hits, cumulative mechanical stress, and tactical encirclement. The Battle of Les exemplified the dual nature of the King Tiger, a machine capable of decimating enemy forces at extreme range, yet fundamentally vulnerable to mechanical failure, attrition, and clever tactical employment by an opponent willing to close the distance and exploit its limitations. The abandoned King Tigers, hulks of raw steel and lost potential, sat silently on the snow-covered fields around Les. Some had been partially destroyed by demolition teams, turrets blown off or engines sabotaged, but others remained largely intact monuments to engineering overreach. American forces, advancing the next morning, encountered these mechanical giants with a mix of awe and disbelief. Intelligence reports had warned of their lethality, yet here they were, immobile and silent, defeated not by enemy fire, but by fuel shortages, mechanical fragility, and the unforgiving demands of winter terrain. For the crews who had abandoned them, the experience was bitter. These were the most advanced tanks Germany had produced, yet they had become liabilities, constraining movement, straining logistics, and ultimately failing at the decisive moment. Piper's withdrawal underscored the harsh truth. Even the King Tiger's formidable armor and gun could not compensate for strategic and operational limitations. American and later, Allied intelligence teams quickly seized the abandoned vehicles. Engineers and ordnance specialists documented every component, photographing, measuring, and dismantling sections for study. The lessons were immediate and clear. The King Tiger's frontal armor and gun remained unmatched in raw capability, but its mechanical complexity, weight, and logistical demands made it a fragile weapon in practice. Mobility and reliability, the intelligence concluded, were as important as firepower and protection. The Ardennes offensive had provided a final, devastating proof of this principle. Germany's most powerful tanks, designed to intimidate and dominate, were immobilized by fuel shortages, terrain, and mechanical attrition. The King Tiger's myth of invincibility had collided with operational reality, leaving a legacy of both awe and cautionary tale in armored warfare that would influence post-war tank design and doctrine for decades to come. Tank 332, like 213, was largely intact when discovered. Sergeant Glenn George and his crew were initially cautious, fully aware of the King Tiger's fearsome reputation. After careful inspection, they confirmed the tank was abandoned and no longer operational. The Americans documented the vehicle thoroughly before towing it back to a secure location for further study. Engineers and ordnance teams dissected the tank, cataloging every component from the Maybach engine and final drives to the 8.8 centimeters KWK-43 main gun and Zeiss optics. Testing at US facilities provided valuable insights into the strengths and vulnerabilities of the King Tiger. The frontal armor and turret were virtually impervious to standard Allied tank fire at range, while the main gun's penetration capabilities far exceeded any Allied equivalent at the time. However, as with Tank 213, the mechanical system's transmission, suspension, retained, and engine showed the same weaknesses that had plagued operational units in the Ardennes. Fuel consumption, limited mobility, and susceptibility to mechanical failure were confirmed through controlled trials, cementing the lessons already learned on the battlefield. Tank 332 was eventually preserved as a historical artifact, though unlike 213, it was moved to a museum facility rather than remaining in situ. Over the decades, restorations repaired damaged components, placed worn track links, and stabilized the chassis for display. Today, it serves as both a technical case study and a tangible reminder of the operational realities behind the Myth of the King Tiger. The histories of tanks 213 and 330 to encapsulate the broader story of the King Tiger. Machines of extraordinary engineering and battlefield potential, yet ultimately constrained by mechanical fragility, logistical demands, and the harsh conditions of war. Their preservation allows historians, engineers, and the public to engage directly with the material legacy of Germany's most famous supertank, bridging the gap between legend and reality. Tank 332's long post-war history highlights both its technical significance and its role as an educational artifact. The cutaway display at Fort Benning allows visitors to observe the internal workings of the King Tiger firsthand, the cramped crew compartments, the placement of ammunition racks, the Maybach HL230 engine, and the complex transmission and final drive systems that so often failed in the field. Its preserved state provides a tangible link to the operational challenges faced by crews during combat, as well as the engineering triumphs and limitations of the vehicle through decades of examination and display. Tank 332 has become more than a relic. It serves as a teaching tool and a reminder of the realities behind wartime legends. Engineers, historians, and military enthusiasts can study the balance between armor, firepower, and mobility. Understanding why the King Tiger, despite its formidable specifications, was ultimately constrained by logistics, mechanical fragility, and operational context. Unlike Tank 213, which remains a memorial on its original battlefield in Lass, Tank 332 represents the broader story of American technical intelligence and preservation. Its journey from a frozen Belgian battlefield, through decades of examination and outdoor display, to its current home in Fort Benning, underscores the enduring fascination with the King Tiger and the lessons it imparted. As the only intact King Tiger captured by American forces, it embodies the paradox that defined the supertank, a weapon of unparalleled potential, yet a machine whose true capabilities were perpetually limited by the realities of war. The realization that King Tigers could be neutralized without direct combat reshaped Allied tactics and morale. American and British tank crews became more confident, approaching encounters with measured caution rather than fear. Intelligence bulletins emphasized exploiting terrain to induce mechanical stress, targeting flanks and forcing movement rather than engaging in frontal duels. The psychological advantage that Germany had sought with the King Tigeran aura of invincibility was eroded, replaced by practical understanding of its limitations. For German crews, the contrast was stark and demoralizing. Veteran tankers, who had once trained to rely on overwhelming firepower and near-impenetrable armor, faced the bitter truth that their supertank often failed before reaching the enemy. Reports of immobilized vehicles, destroyed not by enemy action but by breakdowns, undermined confidence in equipment, command, and ultimately in the broader strategic situation. Units had to allocate scarce fuel and maintenance resources constantly to keep the few operational tanks moving, leaving them vulnerable elsewhere. This dual perception, fear and myth on one side, frustration and disillusionment on the other, shaped armored operations for the remainder of the war. Allied forces leveraged the King Tiger's logistical and mechanical weaknesses, while German crews adapted through procedural modifications, improved maintenance, and more cautious tactical use. Yet by late 1944 and early 1945, it was clear that even the best crews and the most diligent field repairs could not overcome the fundamental limitations imposed by the tank's weight, complexity, and voracious fuel consumption. The story of the King Tiger, therefore, became a lesson in both psychology and engineering. A weapon designed to dominate through brute force and technical superiority, but whose practical impact was limited by reliability, logistics, and operational realities. The invincible monster was not defeated solely by Allied guns. It was defeated by its own design, the harsh demands of war, and the unforgiving environment in which it operated. The operational implications of these maintenance challenges were profound. German commanders had to plan every movement with painstaking attention to mechanical limits, often prioritizing vehicle preservation over tactical opportunity. Rapid advances, flanking maneuvers, or forced marches became exercises in risk management rather than aggressive maneuver warfare. A single mechanical failure could immobilize a tank and jeopardize the entire formation. Leaving both the crew and nearby units exposed, American and Allied forces quickly learned to exploit these limitations. Intelligence reports emphasized that forcing King Tigers to move repeatedly, cross difficult terrain, or engage in prolonged marches increased the likelihood of breakdowns. Road-bound tanks became predictable targets, and mechanical attrition could be as decisive as enemy firepower. Crews reported abandoned King Tigers with engines seized, tracks thrown, or final drives. Destroyed tanks that were otherwise undamaged but useless in combat. The complexity also strained airman logistics to the breaking point. Spare parts were scarce, recovery vehicles were limited, and specialized technicians could not accompany every unit. Even when a broken King Tiger could be repaired, the time and resources required often outweighed its tactical value. Comparatively, simpler designs like the Panzer IV or Sherman could be returned to action quickly, sustaining operational tempo and reducing vulnerability to attrition. In practice, the King Tiger was both a psychological weapon and a logistical liability. Its crews faced constant stress, balancing the potential to dominate in combat against the ever-present risk of mechanical failure. Each movement, each engagement required careful calculation, and even experienced crews could do little to mitigate the fundamental engineering limitations imposed by the tank's immense weight and intricate design. The legend of the King Tiger's invincibility was repeatedly undermined, not solely by enemy action, but by the unforgiving realities of maintenance, supply, and mechanical endurance. The disparity in production capacity revealed the true cost of the King Tiger's engineering ambitions. While the tank was technologically impressive, its massive weight, complex drivetrain, and maintenance demands meant that each unit consumed industrial resources equivalent to multiple medium tanks. In contrast, American factories could produce large numbers of reliable, easily maintained tanks like the Sherman, ensuring operational flexibility and numerical superiority on every front. The King Tiger's reliance on specialized recovery equipment further compounded its limitations. A transmission weighing over half a ton could not be replaced in the field without jacks, hoists, and trained technicians. Final drives, suspension repairs, and track replacements required similar resources. If a tank failed, recovery was a logistical challenge, not merely a tactical inconvenience. Allied intelligence and field experience showed that these mechanical vulnerabilities often removed King Tigers from combat long before they could engage the enemy. Strategically, the production bottleneck and resource intensity of the King Tiger meant that Germany could never match Allied quantities. For every King Tiger deployed, the Allies could field over a dozen Shermans, a force that was not only numerically superior but operationally sustainable. The contrast between German engineering brilliance and American industrial pragmatism underscored the decisive role of logistics and production in modern mechanized warfare. By war's end, the King Tiger had become both a symbol of engineering audacity and a cautionary tale. It could dominate in ideal conditions, but the combination of mechanical fragility, fueled demands, and industrial inefficiency ensured that its battlefield impact was far less decisive than its reputation suggested. Where the tank's firepower and armor impressed, its operational constraints limited its strategic value, ultimately reinforcing the principle that quantity, reliability, and logistics often outweigh raw technical superiority in total war. The story of the King Tiger became a case study in the balance between capability and practicality. American engineers and military planners internalized the consequences of over-engineering. A tank's battlefield potential was not defined solely by firepower or armor thickness, but by its ability to move, operate, and be maintained under combat conditions. Every innovation had to be weighed against reliability, ease of repair, and logistical sustainability. This philosophy informed the design of post-war American armored vehicles. The M48 patent emphasized standardized components and maintainable systems. The M60 incorporated robust engines, transmissions, suspension systems capable of sustained operations across diverse terrain. The M1 Abrams later combined formidable firepower with advanced yet maintainable systems, ensuring that tanks could reach, fight, and survive on the battlefield without being crippled by their own complexity. American armored doctrine evolved in parallel. Training, maintenance, and logistics were elevated to central importance. Crews learned to respect the limitations of their vehicles, while designers ensured that critical systems could be repaired quickly, often under fire. The principle was clear. A tank that could not reliably reach the fight was effectively useless, no matter how advanced its armor or weapons. In the final analysis, the King Tiger's legacy was paradoxical. It symbolized technological brilliance, yet highlighted the dangers of overcomplicating engineering at the expense of operational reality. Its failures, meticulously documented by Allied intelligence and field experience, shaped an entire generation of American tank design, emphasizing reliability, maintainability, and practicality lessons. Born from observing one of the most powerful yet fragile machines of the Second World War, the King Tiger's fame, therefore, rests as much on perception as on performance. In propaganda, film, and popular imagination, it looms as an unstoppable force, embodiment of German engineering genius. In reality, its operational history told a more nuanced story. Its power was undeniable in isolated engagements, yet the combination of weight, complexity, fuel consumption, and mechanical fragility limited its strategic effectiveness. The lessons of the King Tiger extended beyond wartime accounts. Allied forces, through meticulous study of captured vehicles, learned that raw technical superiority could not compensate for logistical and operational shortcomings. Reliability, maintainability, and industrial scalability proved decisive. The King Tiger demonstrated that a weapon system, no matter how formidable on paper, could fail spectacularly if production and support could not keep pace with battlefield demands. In the end, the King Tiger became a symbol not of battlefield dominance, but of the mismatch between Germany's engineering ambition and its declining industrial capacity. Its story highlights a central truth of mechanized warfare. The most powerful weapon is only as effective as the system that sustains it. For all its legendary firepower and armor, the King Tiger was a tank that often never reached the fight, and when it did, it was as likely to be defeated by its own mechanical limitations as by enemy fire. Its legacy lives on, both as a historical artifact preserved in places like LA's and Fort Benning and as a cautionary tale in engineering and military planning. The King Tiger remains a marvel of design, but also a reminder that in war, practicality and sustainability often outweigh raw technical brilliance. Abandoned King Tigers of 1944 became more than mere wrecks of war. They were evidence of a fundamental truth about industrialized combat. They showed that technological brilliance alone could not overcome deficiencies in logistics, production, and operational planning. Each immobile hull told the story of wasted resources, shattered expectations, and the limits of engineering when divorced from practical realities. For American soldiers, engineers, and strategists, these discoveries were transformative. The fear of an invincible German weapon was replaced by the sober understanding that superiority in numbers, reliability, and sustainment was decisive. The King Tiger, for all its formidable armor and gun, could not survive the demands of real-world warfare without fuel, spare parts, and extensive maintenance. Its failures were emblematic of Germany's broader industrial and strategic limitations, a microcosm of the mismatch between ambition and capability. This lesson extended far beyond World War II. It shaped the design philosophy of post-war armored forces, instilling a focus on maintainability, reliability, and logistical support alongside firepower and protection. The King Tiger's brief moments of battlefield dominance could not outweigh the strategic consequences of mechanical fragility. In the end, its true legacy lay not in the destruction it inflicted, But in the insight it provided, a reminder that the effectiveness of a weapon is measured not by its specifications, but by its ability to operate consistently, reliably, and sustainably in the realities of war. The story of the King Tiger endures as both legend and cautionary tale, symbol of engineering ambition constrained by practical limits, and a lesson in the enduring primacy of reliability and logistics over raw technical sophistication. That, above all, was the real story of the King Tiger.